All right, good morning, everyone. It's 10 o'clock Mountain Time. We'll just get things kicked off in a sec. We'll just wait for a few more people to hop in. So we'll give everything about one more minute before we start. All right, well, we got a few more people joining here. So we might as well just get started. This will be recorded so we can access it afterwards. So just want to welcome everyone here today. So good morning, everyone. My name is Kevin Grover. I lead the customer success team here at Look. And today we've got another webinar series, a short half-hour webinar on overhead utility capture. So we're going to be just talking about best practices for how to do, I guess, proper field capture. And then in the other webinar series, we're going to get into some other use cases on how to use the data downstream. But this one's going to be specifically around the field capture for overhead utilities. So I will get things kicked off here. Oh, sorry. Oh, there we go. So yeah, so if you'll do a really quick overview of the Look platform in general, I think most people will hopefully be familiar with it, but we are a handheld photogrammetric capture system. So we use multiple cameras on the device. We've got survey group GNSS on the device, and we also have onboard AI processing for doing some of the in-field analytics and making the data more intelligent kind of right off the bat. We do get into our QAI, which is our processing solution, and that gets into how we actually are able to generate the georeferenced high resolution models and the 2D and 3D data products you can export. QApp is our web application, which is what is needed because we are cloud-based for all of our processing. It allows you to view, share, analyze, and work with the data kind of within our web application. So how does it work in the field? It's pretty simple, actually. We're a small handheld system. So we are looking at, it is basically a field capture. So you're walking around with the device. It does have real-time, it's got PPK GNSS corrections on it. So we post-process the GNSS corrections and you're able to capture overhead power. We're able to use it for survey applications, underground manholes. We're able to use it for a number of different things, but it is basically meant to be a simple solution, and how to collect data in the field is pretty simple. We'll get into that in more details when we get into the workflows. As far as the office side, once it's collected, we basically make it easy on this piece is you upload the data to your our web application. We have a secure web portal, and within, I think we're kind of more 12 to 24 hours. We say 24 to 48, but it's typically 12 to 24-hour turnaround time. And that's actually is allowed or able to generate a 3D point cloud, ortho image, and other 3D data products within the viewer. We've got tools to do extraction within the browser as well. So we've got some, I guess, an example of a poll, and we can actually use our virtual surveyor tool to do extraction. We can also work with some third-party applications, and all the data is exported in agnostic format. So with the point cloud, ortho imagery, and we've got some other integrations that we're working on as well. So in the end, what we're able to generate is something that's going to look like this. It's a three-dimensional point cloud that is very precise. So we're able to take precise measurements kind of in, for heights, pole to pole measurements. We're also able to do more absolute measurements because we are GNSS based. So the data set is going to be linked to a coordinate system. You can fit it to ground control. So we can start generating more survey grade products from the data set. But this is really what we're expecting out of the quality of data in the end. And this is just from a simple walking capture at the ground level. So as for best practices, like I said, this is specifically going to be for overhead pole, but we do have some just general best practices for how to use the device specifically. So because we're handheld, we do want to kind of, again, we say to hold it like a coffee cup. So it's basically meant to just walk stable, hold it out in front of you. Of course, you wouldn't invert a coffee cup, but our device can be inverted. So you can actually invert the device and flip it upside down. This is kind of one of the benefits of our product is we don't need to have GNSS corrections all the time. You can actually invert it, and this is what we do for a manhole capture. Specifically for overhead power, it's rare you would ever invert it, but it's possible. We do capture at a mild walking pace. And I will say mild walking pace. We can do faster walking pace. We can do slow, kind of, I'd say scooter vehicle capture, but I'd say definitely kind of under that 5 to 7 miles per hour is really kind of that threshold we're after. So you don't have to walk slow. The important thing is to make sure we do get the coverage that's needed. So some of the things we do want to look at a snaking pattern. We'll show that in a more of an example here of what that means. But the benefit is, the big thing is you don't want to do fast, jerky movements, fast turns. We want to keep it pointed ahead of you, not being visible in the devices and in the images, so don't have it pointed and staring into one of the side cameras. And then also being not too close to vegetation. So this is one of the limitations of it is, of course, we can work in and around vegetation, but really dense foliage is always going to be a challenge. So we want to kind of keep that 1 to 2 meters or kind of 5 to 8 feet away from kind of from any vegetation within a data set. It's harder for us to reconstruct when that happens. Other best practices with it, we have extended this capture time. We used to have a 20-minute capture limit. We can comfortably do up to about a 30-minute capture limit. Ideally, this is going to depend on the application that you're doing. And this is per data set. But for large areas, you can tile it into multiple captures. The goal is to have independent captures done from one another. So you don't want to kind of do two captures within the same area. You want to do kind of tile into area A, B, C. But we'll talk about that a little bit more as well. The local GNSS base station does improve accuracy. We have an auto processing solution that is just a global GNSS processing that gives us corrections kind of across the globe. It is limited in certain areas, and that's just based on coverage. So the shorter the baselines for the GNSS processing, the better the data can be. So we're looking at some options to help improve that as well. This isn't necessarily what we do for a lot of the overhead power applications, unless you're doing more survey kind of workflows for overhead power. You can align to control using ground control points. This is kind of where we can now start nailing it down in the absolute sense of where the data is in the real world. So all things that are possible with it. The last one, of course, is capture in suitable weather conditions. Of course, being image-based, we want to avoid kind of capture in rain and snow conditions. You can capture when it is wet on the ground or even a very light rain. The problem is just we can't have a lot of, adverse weather conditions that are impacting the actual collection. So like water droplets being collected on the device itself. So. But snow cover is definitely possible, and we're working on this here as well to improve the applications of where we can use this in different weather conditions as well. Now we're going to dive specifically into power line capture and the workflow for how to do this specifically. So we'll get into the actual. I'll kind of do this stage by stage. We're going to start with the actual pole capture. So it's important, being a photogrammetric site system, it is important for us to get proper capture of whatever we can see. We are based on line of sight. We can only basically extract and process what we can see. So around a pole, we've got kind of two opportunities here. We want to be able to fully circle around a pole when possible. So in this case, in the image on the left, done just a single circle around. Ideally, if you could circle around the pole twice is great. This would be circling around it once, kind of pointed more to see the entire pole. Maybe you want to circle around a second time and back up from it, or lift the device up a little bit higher and you do a second circle. That will just give us more data on the actual pole itself. So when you're really concerned about the attachment points or infrastructure on it, or maybe it's a bit of a taller pole, this is where it's going to be beneficial to do probably that second loop, provided you can fully circle around it. Of course, being work in the field, the ease of walking directly around a pole is always going to be challenging. So this is where ideally you can do 2 half circles. So same type of thing, you walk around a half circle pointed to the pole, you walk around a second time at a separate distance or raise it up higher. The goal again is just to get as much data captured for the pole as possible. It's still pretty quick for the capture per pole. Like it should be spending, not even minutes per pole. It should be like a minute per pole is basically what can be done to walk around it, collect even your tag, and basically be able to do it from there. So for doing the pole capture, this is really the beneficial part of it. And make sure you can see the top and the bottom of the pole. We can only reconstruct what we can see. So definitely being able to do this and seeing the entire pole. So keep that in mind when you're doing the actual collection around each individual pole. Kind of diving into the planning of the capture areas, this is kind of where you do want to break it up into sections. So now as we start going from pole to pole and we want to start going along linear kind of captures, this is where we want to keep that limit. Oh, I did have this as 20 minutes. This is where we can ideally do up to 30 minutes. It will take a little bit longer to collect, but for a 20-minute capture, you can typically do about 8 to 10 poles in a single capture. This gives you the time to actually circle around, do the collection at the pole itself, and then do the collection from pole to pole. So some of the important things here is honestly coming up with a naming scheme, how to organize your data, manage your data products, because basically we're allowing you to collect the data in the field and allowing the web application, but we do display it as one large data set. We can see all these individual captures in our web viewer, but it's important just to have some very simple things done on your side, is come up with a naming scheme, come up with a way to break up your data set kind of in the field. So you're kind of strategizing around even how many captures you need, making sure you've got the proper coverage as necessary. So the other important part is to make sure you start and end your capture at a pole. So we do want to have overlap between captures. So this means that your end of your capture 1 will finish at a pole and your start of your capture 2 will be for that same pole. The benefit around this is that it allows us to link these together. We can get measurements at the pole itself, but accurate measurements from pole to pole. So all things to work on. We're looking at improving and extending how long the captures we can do. So in the end, this won't be as big of an issue. But for now, again, make sure you're kind of getting that proper overlap as we can kind of build out these models a little bit more detail. So on the pole side of it as well, we can also attach capture pole tag information as well. So this is where at that pole side, you can actually walk directly up to the pole. We've got a point of interest button that can be pressed on the capture. This allows us to take another image at a specific location. So it'll actually be tagged differently in our application. So the benefit of this is that it'll be tagged, I think on the last screenshot, there were some green dots you might see on the map. This allows us to kind of know that you're actually at the pole. And then when you're looking at it afterwards, when you bring up that marker within our web application, you're going to be able to see exactly what was taken from a closer proximity. So for this, you can be within a foot and a half of the pole, and this allows you to get a really high level of detail at the pole itself. So this is important. Just if you need this extra information, it allows you to walk up to it and get this tagged differently within our platform. So now when we start moving on from pole to pole, so there is kind of a way that we want to walk to basically get the proper capture. So in this case, you see where the 2 green dots are, is we do see where they capture the 2 green poles. This is the point of interest at the pole to pole. This is a snaking pattern. We're looking at walking from pole to pole. The benefit of this is it actually does allow our reconstruction engine to just work better, to constantly change the imagery geometry as we're walking from pole to pole. So by walking in this, we call snaking pattern, drunken sailor, whatever you want to call it, to kind of walk from pole to pole. It just allows us to kind of change that geometry. Then we do the 2 half loops in this case because there's vegetation on the, I'd say the south half of this pole line. You do the 2 half circles and then you continue on. So you want to make sure that you do this along the way. The benefit of this is you also want to be at a bit of an offset from the actual power line itself. So the note at the bottom is try not to walk directly below the power line, because we can't actually see all of the lines if you're directly below it. Just they all are vertical above you. We do want to make sure you can kind of see at a bit more of an angle. So ideally, if you can walk, a little bit adjacent to it. So I say 3 to 5 meters, 12 to 15 feet adjacent to the wires is ideal. The benefit of this is also like walking where you can, again, the path of least resistance, which I'll show you kind of the next, I think, example here too. So walking pole to pole is important. Get that proper overlap as you're going from pole to pole. So again, walking in heavy vegetated areas, this is just kind of an example, is the worst thing we want to do is actually walk directly into the line. You can actually, it's hard to see here, but there are lines running just above the vegetation. So you want to walk in the path of least resistance. So the more open areas you can walk in that can see the the poles and the wires kind of from kind of that offset. Make sure you're walking down, rolled shoulders, pathways, sidewalks, that kind of thing, rather than walking directly in the ditches or trucking through like heavy vegetated areas. So the benefit of this is you're able to see it. We can reconstruct better. We'll have kind of better GNSS data in this example here as well too, is that we can actually will have just better GPS coverage. The precision is going to be a little bit better. And we can also see more information, I guess, from the side. It's always going to be challenging in and around vegetated areas. So these are some of the things that you just have to be cautious about when you're planning these things out. Whereas, like I said, we're based on line of sight. So still, if you can walk down the edge of the road, of course, allows you to avoid traffic conditions and walking kind of in a safer environment. But just from even walking on flatter surfaces is safer for your field crews too. So when you do get up to poles, or if you do need to get more detail, you can enter into the kind of the environment with the capture and kind of back out of it. But you want to try to make sure that we're able to reconstruct it from as being in the least vegetated areas if possible. In the cases if we do need higher accuracy, all of these examples more so has been kind of walking from single pole to single pole and walking just once between them. This is where if you do ever need increased accuracy for whether it is maybe a higher geospatial accuracy of the poles themselves or where the wires are, we really care about like that 3D positional accuracy of the data. This is where we actually want to probably look at doing, I'd say I keep going back to more of a survey capture. This is where you start getting more overlap in your capture. So in this case, we've walked this power line in 2 passes. So the pole is actually centered around where it's circled here, but we've walked it at parallel offsets on the 2 sides. We're still doing the snaking walk and doing the circles around the poles kind of once or twice, but the benefit of doing the more overlap is it allows us to do a denser reconstruction, and the overall global accuracy of the data is going to be even tighter. So when you're not concerned about, when you're only concerned more about, I could say, the relative measurements, so you only care about maybe a pole-to-pole measurement or the measurement of a height or the height of a clearance, this tends to be a bit more overkill. But if you do want to get that higher 3D positional accuracy, is where if you walk it in more passes, you could walk it in a 3rd pass if you really wanted to, and then you're just going to get more data to reconstruct and generate a better data set. Also, this is where running like a local GNSS base station is going to improve the results as well. So this is just a typical GNSS workflow. Is the shorter the baseline, the more precise your post-processed kind of accuracy will be. So if you're really concerned about that tight accuracy, running a local base, or even in the last one here is actually running our align to control tool, which allow you to actually link the data set to survey control points. This is kind of where now, if you really want to nail it down in the real world, that's where you want to start looking at doing it from a higher precision there. So lots of things we can do on that side. So just in summary, we got a nice little video. This is actually Lucas's video that we did, our VP of product. We've got this as one of our best practices, just again, to walk through what we're doing. So circling around the pole, in this case, if you can fully circle around the pole, that's the benefit to do it. Circling around the pole capture again, but doing it at a different proximity to the pole. This is the basically to get the best geometry, the best capture at the pole itself. Is doing at the offsets here. So this is where it's important to walk in the snaking pattern away adjacent from the line. So you see him kind of doing a bit of a snaking pattern back and forth. It adds just that bit of variation when you go from pole to pole. Then at the pole itself, if you can't actually do the next pole as the full capture, you see there's a lot of vegetation on the one side. You want to make sure we're walking the 2 parallel offsets or changing the height of the capture as you're walking as well. So just to summarize, that's kind of really how we're looking at doing that pole to pole capture. You'll notice that the collection itself at the pole is very short. We're not spending a lot of time on it. We want to be able to cruise through and actually collect quite a bit of capture on foot. And the ground-based capture does allow you to capture things like the pole tags and things like that, as well as you're doing this from the ground-based platform. So of course, everybody asks, things to avoid. There's always some things we've kind of had a lot of challenges for just capture scenarios and things to kind of worry about as you're doing this in the field. So some of the things, like I said, dense vegetation. We've had this captured in a lot of things. We can't collect, and we can't, we have a really hard challenge of doing very, accurate 3D positioning within dense vegetation. So this in case was probably a cornfield, impossible to reconstruct. So challenging things with is you want to remain away from the vegetation. We have about that 1 to 3 meter buffer that we want to stay around. So this is kind of where that you want to walk in the areas we know we'll be able to reconstruct, that you can still see the pole information, kind of the overhead lines, but avoid walking through dense vegetation like this. The other issue is, yeah, you see like the hand coming in. So you want to avoid moving objects within the capture path. So of course, this one's a little bit challenging that it is very dense vegetation, but at the same time, we want to avoid moving things out of the path. The reason why we would want to avoid this is, of course, that the environment is actually changing that you're capturing when you're doing it in an environment like this. So we're moving branches, we're moving trees. So we do rely on our photogrammetric reconstruction to have objects static within the collection so we can fit them together. So avoid walking through, especially in dense vegetation, and pushing things out of the way. What you would have to do in a scenario like this is, hate to say, you may have to kind of clear some of this ahead of time, or maybe just find an alternate path that you can actually walk through to avoid doing things like this. One of the things is climbing fences, the other bane of our existence too. You can climb fences, but the thing you have to do is basically keep the device pointed upright. We know that there's a lot of logistical challenges of walking in some of these rural areas, or even in and around other equipment and features. So what you want to avoid is when you're walking, you want to avoid dumping the device and being able to, basically us not being able to keep tracking and image match and having proper GNSS. So if you do come up to climbing a fence, use caution. Of course, you want to climb in a safe spot. You want to avoid it if you can, but keep the device pointed upright as much as you can. That allows us to continually get the GNSS signals, allows us to get the corrections all the time, and also allows us to keep the tracking, and we're not basically dumping the device and basically seeing a whole bunch of vegetation when you're doing it. So some of the things, again, most of these examples are in areas of dense vegetation in general, but keep it upright, avoid that fast, jerky movements of things, and just we'll get some better data in the end. Kind of gonna be wrapping up here is just, in conclusion, like the things we want to kind of do, if part of it is best practices on your side to get the most accurate, kind of pull modeling, pull loading. Other ways that we want to kind of get the survey quality data for overhead utilities is just kind of keep in mind a few of the best practices, of course, is up at pre-plan your capture. That's one of the best things we can plan out ahead of time, is make sure you know how many captures you're going to be able to do. Kind of make sure you've got the proper overlap you're going to be able to do. If you do require to have specific polls captured, we're still, reliant on yourselves as our customers to do the proper capture yourselves and make sure you're collecting everything that's needed, making sure you've got everything before you leave the field. The other part is the quality GNSS corrections. We do rely heavily on GNSS corrections for overhead power conditions. So make sure, like I said, that path of least resistance. Walk in areas where it is more open. Use a local base if you can. Again, we want to make sure that we're able to keep that GNSS corrections as best as you can through as much as possible. So maybe there are areas where there's a bit more dense vegetation. That can be solved by even raising the device up a bit higher. We've got different pole mounts that you can use with it as well. So maybe you've got to get it a couple of feet higher up in the air just to kind of get a little higher off the ground to get better satellite coverage. All of those things can help, just being heavily reliant on some of these things on our side. The last one is, of course, limit captures in heavy vegetation. We can't make miracles out of our data. So that is one thing you want to avoid. So like I said, whether it is walking in the certain areas to allow you to capture in a different way, maybe it is kind of pre-clearing some of the area ahead of time. I know that that's kind of adding a second trip, but of course, these are all things that are challenging with really any technology. If you can't physically see it, it's really hard to measure. So that's it from my side. I know we've got 25 minutes here, so I think I timed it quite well. Anyways, thank you very much for joining. We will allow people to come off of mute if there's any questions that you've got, but maybe before we do that, I'll just do one kind of final wrap up here just before we get into questions, just for some announcements. Teresa, do you want to come off mute to talk about this, or you want me to chat through it?
Sure. Just a quick reminder that the next webinar is coming up on Tuesday, December 16 on understanding process data. And you can go to the webinar series page and register from there. Just as a reminder, each one of them, since we're hosting in Microsoft Teams, you have to register individually for them. So I put the registration link directly in the chat if you want to go ahead and register now so that it's on your calendar. And then the webinar series page is live. You can go there anytime and register for upcoming, as well as get the recording for previous sessions. Just like this one, it will be recorded and we'll have that available soon after the session. Thanks.
Perfect. Thank you so much, Teresa. And just so everybody knows, in the chat, if you go there, yeah, she added in the chat for where you can register and also see in the other webinar series. So that's it on my end. We got a few minutes here left. If anybody does have questions, feel free to put them in the chat, or feel free also to raise your hand and come off mute, and you can ask it live here. And if nobody has questions, we can end a couple of minutes early, but I'll wait around for a few minutes in case anybody does have anything. So, oh, Richard said he put a question in the Q&A. Oh, awesome.
There you go.
Yeah, you invert it for a pole attachment of the handle. Let's see, has anyone thought of using this pole to place a device over regular fences that might align an alley to extend the survey to the surface and features on the other side of the fence? Loaded question, but yeah, no, great. So as far as the attachment itself, so we do provide just the handle on the underside of it. It's just a basic pistol grip. You can actually fully remove that handle, and there's a little rail on the underside of it. So there's some options to basically remove that. And on the underside of it, we've got a 1/4x20 camera thread. So you can really kind of add on any camera attachment or any pole attachment to it. So really, if it's a monopod or something like that, you can thread into it. There's an adapter that we can also kind of send a link out to. There's an adapter to go to like a 5/8 survey pole thread. So you can put it on a survey pole. So really, if you do need to raise it up or invert it into a manhole, is where basically that pole attachment can be used for it as well. As far as, yeah, using that pole to place over a fence, that's actually kind of come up with some interesting things that we've talked about for, again, since we can't do like base of pole measurements, or even if there's vegetation in a ditch to be able to do it. Those are some things we're considering for kind of future iterations of being able to have like more of a known height of the device and being able to get more ground data out of it. We don't have that operational yet, but it's kind of come up with something of interest. But typically right now, the pole is just more so to get it basically a better field of view for where we're going to be collecting from. But we got some other ideas we're going to be looking at in future versions of hardware and kind of our processing stack. But right now, yeah, just easier ways to get the device in and around into different scenarios. That answer your question, Richard? Oh, I see you get some other chats here. So I'm a surveyor. Perfect. My interest in a ground survey, not poles, wires. Yeah, great. That's why we got this webinar series. So this one is specifically around pole capture. We did a survey one 2 weeks ago. So feel free to go and check out the recordings of the past webinars. The one in 2 weeks is going to be looking at just the data that we process from our platform anywheres. It's going to be basic, we're going to be looking at point cloud data and ortho imagery and really kind of agnostic to industries, looking all of the data from it. We're going to have another accuracy one. I think that's the one we're going to have for surveying in January. That'll kind of get into how we can get the highest precision accuracy with the Look products as well. So yeah, topolick streets and parking lots. Yeah, that was the past recording. So awesome. Michael's got a question here. Is an approximate max wire height? So I'd say for distribution lines, we do really, really well. Transmission, I'd say we will struggle with getting the wires at the top. So I don't really know if we've got a max range. A lot of it is going to be based on even the density that you capture. Because we're image-based, if we can technically see it in the data, we'll be able to do it. It will be a little sparser at the top. So like large, the structural steel transmission towers are going to be harder to generate for sure. So typically, I'd say like the larger wooden pole capture is definitely doable. But again, with a denser capture, we're going to be able to do it. We are looking at extending our range right now, and that's how, based on just the way that we basically do the photo matching to generate the data set, we will look extending it now. So max is just kind of a relative one at the moment. We don't have a true threshold on what it could be, but it will be challenging for larger transmission. If it's quicker to come off mute, feel free to come off mute if you got the answer. So, or if you want to ask a question. Still see people typing, so. So Richard, yeah, my biggest takeaway is you need to have a plan for how you're going to walk the site, where control will be. I think a lot to be for the chew time, but yeah, we look forward to trying to get again. Awesome. Perfect. No, I appreciate the feedback. And yes, really with like any technology, it's only as good as your capture. So we do have best practices. We are making it easier to do the collection, but we're making it simple for how people can do the capture in the first place. So appreciate that feedback, Richard. But yeah, I'd love to connect to see if you want to try it again. So awesome. Well, I think we're at time here anyway. So if anybody does have follow-up questions, feel free to just fire them our way and we can get back to you. So thanks very much, and we'll see you at the next webinar. Take care, everyone.